Astronomers detect a signature of life on a distant planet. Strongest hints yet of biological activity outside the solar system. Astronomers have found the most promising signals yet of alien life on a planet beyond our solar system. Do you come to Hank's channel to get the real scoop on the real news and whether or not this is a big news or a little news? Not today, you don't. But I am going to tell you how science works, and that's going to be even better. So there's a few different ways you could imagine finding life elsewhere in the universe. One is like radio, just like we get a radio broadcast from another planet, which is like not impossible, but it's pretty unlikely. And that just wouldn't be like life, that would be intelligent life. And as we know from Earth, intelligent life is much more rare than life. We had like 4 billion years of yes life, but no radio, and like 100 years of yes life and yes radio. And like 4 billion years is like 25% of the age of the universe, so that's a long time for life to be in one place. 100 years is 0% of the life of the universe. We're gonna round down. It's more exciting, for sure, to find intelligent life elsewhere in the universe. But it would also be very exciting to find any kind of life elsewhere in the universe, but they don't yell in the same way. And so just finding life, we're pretty much stuck with two options. One, we find it in the solar system, which is possible, but we're not going to talk about it today. Number two, you find definitive signs of life in the atmosphere of another planet. And you're saying, Hank, you can see the atmosphere of an exoplanet hundreds of light years away. Maybe not hundreds of light years, but like, yeah, 100 light years away. How far away is this star? It's 124 light years away. I'm comfortable saying hundreds. It's an exoplanet orbiting a red dwarf. It's a long way away. It's a sub-Neptune at 2.6 times the radius of the Earth. It's a 33-day orbit in its star's habitable zone. It receives approximately a similar amount of sunlight as the Earth, so it's a lot closer, but the star is a lot dimmer. So like a cool thing is that we already know that there are a bunch of kinds of planets that we don't have in our solar system that are actually fairly common. And a sub-Neptune is a planet like that. There's a bunch of these. We don't know what they're like, though, because we don't have one in our solar system, so we have to make a bunch of guesses about what they might be like. But there's something very helpful about them, which is that they have big, fluffy atmospheres. So they have hydrogen atmospheres because hydrogen is so light, they go out farther. So they can be plenty dense at the bottom, but like there's just more fluffier atmosphere. And this is good for our potential ability to detect life, not intelligent life, but little microbes on other planets. Because if an Earth-like planet with our tiny atmosphere all bunched together around the surface, those more dense molecules of oxygen and nitrogen, there's not going to be a lot of atmosphere that the sun's light is passing through on its way to us. There's just a bigger, fluffier atmosphere that more of the star's light passes through, so you have to collect less data with less sensitive instruments to get good data. Or you can collect more data with extremely sensitive instruments and get data you never could have gotten before, which is what happened here. They used the James Webb Space Telescope, which is in many wavelengths the most sensitive telescope ever built, and they could see the spectra that was absorbed by the planet's atmosphere. So you might think that things are like just opaque or not opaque, or just like a little bit see-through. But it turns out that molecules are see-through in certain wavelengths and not in others, because they absorb photons from certain wavelengths, and that has to do with the length of their bonds. And basically, long story short, this means that we can look for specific molecules in the atmospheres of certain kinds of exoplanet. They have to be a certain size. It helps if their atmospheres are puffier, and it helps if they orbit more quickly so that we can take those readings more frequently over and over again. Being closer into the star also helps because they're just more likely to be in between us and the star, because if it's like a little bit tilt, they could still have it be in front of the star, but a further out one would not be occluding the star. If that didn't make sense, don't worry about it. It's fine. But you know what you should worry about is Mother's Day, which is coming up quick, and I just got a package from Good Store, which is our Mother's Day box. And there's a Mother's Day link right here at Good Store, and you can get it for $50. It's just a bunch of delightful stuff that you could get for your mom. Here, I'm gonna unbox it for you. And yes, this is kind of the sponsor of today's video. It comes with a little postcard. It says, "This gift directly supports mothers." For many years, Good Store has been helping to build the Maternal Center of Excellence in Sierra Leone, a place where many women still die in childbirth, but it doesn't have to be that way, and it's getting better because of the work that Partners in Health does. But of course, you don't just get a postcard, you also get garden party soap. This is a soap smell that my wife and I designed together. And she is a mother, isn't she? Also some unscented hand lotion because no one deserves dry hands, least of all mothers. There's also a citrus candle and a bag of Evensong chai tea. It is really delicious and it's a lovely thing to curl up with and have a little sip. You know? Go to Good.Store and give your mom a gift while you also give gifts to moms around the world, because all the profit from everything at Good.Store gets donated to charity. And you can only get this until Monday. So I'm uploading this on Saturday, I think. Hopefully it's not Sunday, but it might be. And if that's not for you, there's also other stuff. You can have a surprise soap club, or 6 months of soaps for $50. You can do the Awesome Socks Club, or the Tea and Soap Club, or just a 3-pack of our excellent, really high quality soaps that we have. Good.Store. Check it out. There's a Mother's Day link right there. But you have to do it now because we have to have time to pack it up and ship it out for you. So do a nice thing for your mom or for a mom in your life. You can go to Good.Store and check out our Mother's Day deals. So there's a bunch of stuff here that's very complicated. Like, I am so far away from understanding exoplanet modeling that I can't even speak to the legitimacy or lack thereof of this paper. I could tell you what they said, but I can also tell you that lots of other people are arguing that the things that they said are overblown or need many qualifications. But the basic thing that they said is that oftentimes, maybe not always, but sometimes, these sub-Jupiters can be well explained, well modeled by a world that is a water world. So like a giant world-covering ocean, hundreds or thousands of kilometers deep, so no chance of any land. And then above that, this like giant hydrogen atmosphere. And depending on how much light could pass through that atmosphere, that water would be warm enough to be liquid, but not so hot that it was boiling away or inconducive to life. That's the idea. And the guy who led the research on this biosignature, this molecule that they think might be a sign of life, dimethyl sulfide. He's the same guy who proposed this new model of an exoplanet that would explain all of their measurements. So basically, like, we get these little hints of the density and the size and the composition of the atmosphere. And then from there, you try and model what these worlds might actually be made of. And his suggestion is that a lot of these sub-Neptunes are what he calls hycean worlds, hydrogen atmosphere, ocean worlds, hycean. And if that is the case, then that's a really good thing for the search for life elsewhere in the universe, because they would have these puffy atmospheres that would be relatively easy to detect chemicals inside of. And they would also potentially have just tons of liquid water, like way more than is in our entire solar system, maybe. And so that's like thing one. Is a hycean world an actual good model for the things going on in this exoplanet? And like, yes, maybe, no, maybe, lots of arguments about that. I'm going to tell you about dimethyl sulfide. It's a sulfur, an element, an atom of sulfur bonded to 2 methyl groups, 2 CH3s, sulfur, 2 methyls, dimethyl sulfide. Dimethyl sulfide is made one way on planet Earth, and that is through life. Actually, it's made in a number of different ways by life, but it is not made by non-living things. There are some ways that you could imagine it being made by non-living things, but those systems would be quite slow. And another thing you want to know about dimethyl sulfide is that in an environment where there is something that will either oxidize or reduce it, it will turn into other stuff. Oxidation and reduction are basically opposite ways of becoming a different molecule, where you either get or lose an electron. Oxidizers include oxygen. So dimethyl sulfide doesn't stick around in our atmosphere very long. It is produced by ocean life mostly. When it is emitted into the air, it reacts with oxygen and light and other sources of energy, and it turns into not dimethyl sulfide anymore. Now, if our atmosphere was instead just hydrogen instead of oxygen and nitrogen, that hydrogen would in short order reduce the dimethyl sulfide, and then there would be no more. Then there is, did you actually detect dimethyl sulfide? Which there's a bunch of reasons why that might be tricky, both involving like the way that they use the instrument being somewhat novel, and so not having a lot of data behind whether or not that's works well. And there's also the fact that like the data we have on dimethyl sulfide's absorption, like what wavelengths it absorbs, is based on it on Earth, where the pressure is at 1 Earth atmosphere. And the atmosphere around it is nitrogen, not hydrogen. And the temperature of the atmosphere is, our temperature, not the temperature of this exoplanet, etc. And so maybe it would have a different absorption spectrum on that planet. Now that's something that's easier to test and actually get to the bottom of. But then if that turns out to be the case, there's still the question of whether or not we're just not understanding all of the sulfur-based chemistry that could be occurring on a planet like this, because things are very different there. And so maybe dimethyl sulfide could be created through non-biological processes, whereas it doesn't really get created very much, only in very weird circumstances, through non-biological processes on Earth. But Earth isn't like this weird planet. And I don't know. Like, this is 100% what I need to tell you. I know that a lot of people in this world who I trust are like, this seems like a weird thing for scientists to say, that it's like our best clue for life so far. In a press release, that seems like the kind of thing that would happen when like an editor who's trying to get clicks got its hands on it rather than a person who's trying to present their science. But look, I can guarantee you that they are going to get more telescope time to continue examining this world, and that is part of the game. I don't know. I don't know the game. I don't know the game. What I do know, though, is how science works, which is that when we look back, we think that we can say that is the moment when we figured out that thing. And so what people imagine is that there will be a moment where we realize that we have confirmed that there is life on another planet. And look, if SETI had worked and we had like immediately found a bunch of radio signals that were hitting Earth and we could like watch space TV, then that would have been a moment like that. But this is the more typical way that science happens, where we look back and we say, that was the moment we figured it out. But what actually happened is there was no moment we figured it out. There was a long process of being like, I think this is the thing. And people being like, have you checked this? This seems more likely to me. What if it's a magma world? Maybe dimethyl sulfide wiggles differently at different temperatures or in different atmospheres. What if dimethyl sulfide could be delivered by comets and then somehow build up in an atmosphere that doesn't reduce it for some, like, it's weird. There's lots of weirdness, and we don't know what this planet is like, and we're like, it's going to be hard to figure that out. So like walking through this as if this planet is the planet where like finally 15, 20, 30 years from now, we settle on a scientific consensus that in fact this planet has, you know, single-celled organisms on it producing, among other things, dimethyl sulfide. Those people then will look back on this paper and on the paper before it and be like, man, it was so smart to figure out that hycean planets would be such a good way to look for biosignatures because they were puffy, but also unbeknownst to us this whole time, a lot of these sub-Neptunes had giant liquid oceans under them. And so seeing that insight was really valuable. And that is why this person in particular and their lab is the person who discovered life on another planet for the first time. That's the story we'll tell. And it will be a wrong story, because that's not what will have happened. Instead, what will have happened is there will be this paper, and then a bunch of people will yell about it, and they will argue, and they will say, this actually, I don't think that your findings support that this is a hycean moon. Actually, I think that there is X, Y, and Z way that dimethyl sulfide could be created abiotically. Actually, we really need to check to make sure that like the absorption spectra of DMS would look like this in that situation that it would be in on that planet. And step after step, after step after step, there would be moments where we could realize that in fact this isn't DMS, or in fact this isn't a water world, or whatever. But also maybe when we do the work, when other labs do the work, when people push back and check this direction and that direction, they fight it out, they argue, they think through the problems. Eventually, you end up at a place of scientific consensus because the challenges have been internalized and then accounted for in some way. Somebody hears the challenge and they say, well, we should check. Here's how we'll check. And then they check. And the challenge either is like, actually, no, that doesn't make sense. And so this isn't a biosignature. Or they check it out and they're like, well, this particular challenge, and there are others yet to come, is not actually valid in this circumstance. So there still is a possibility that this is our first time ever finding life elsewhere in the universe. And here is where my opinion about this comes in. And this is an informed opinion, but it's an opinion. It's like a spicy take. And I love a spicy take, and so do many people. But I think you should qualify and let people know that it's a spicy take. So like when we talk about discovering life elsewhere in the universe, there's always this line of, you know, extraordinary claims require extraordinary evidence. But when it comes to biology, when it comes to living chemistry, I think that we're going to find it because it seems like a chemical inevitability. Given the right circumstances, it seems like life arises. Of course, we only have an N of 1 so far. Like, we've only got this one biological system we know of, so we can't actually say that. But it seems like life formed very early in the history of Earth. It's continued throughout the entire history of Earth since then. It seems like life, this is not intelligent life, which seems quite rare, but it seems like life could easily be quite common. And in the way that when I was a kid, people were fighting to find the first exoplanets, knowing dang well there are probably exoplanets out there. Like, why would one star have planets and the rest of them didn't? And so they were fighting in a way to be the one to discover an exoplanet first, not to be the one to prove that exoplanets existed. That's how I feel about biologies. I feel that we're fighting to find the first one, not fighting to find that they exist, because they definitely exist. Other biologies definitely exist. The standard of proof doesn't have to be as high because it's probably there. Now, the fight is science. And so the fight is the thing that we have to do. Is this proof of life on another planet? No. Does this planet have life on it? We don't know. And in a way, like, that we do know that many other planets don't have life on them. But, you know, there's something clever here to trying to think through a bunch of different potential models of what exoplanets might look like, given what little information we have about them, and to identify a potential candidate model for a sub-Neptune that would be a potential life factory. And like, if you find a ton of DMS and there's a ton of water, that makes sense because water organisms create DMS in various ways. And so this planet, from what they detected, which if the detection is correct, which is a big if, would be like way more DMS than we have in our atmosphere. That is exciting, but we have to understand way more about the chemistry of this exoplanet. However, given the spicy nature of the press release, it makes me think that we are likely to get a lot more of that data. Now, we don't necessarily have much more useful instruments than what have already been turned on it, but we do have other techniques that we can turn on it. We have more telescope time that we can give to this, and we have more fighting that we can do. We have more like looking at spectra and figuring out more things about how we could potentially model this exoplanet in a way that would explain everything that we know about it. If at the end of that, we understand that the atmosphere of that planet doesn't make any sense without biology, then perhaps in who knows how many years there will be scientific consensus around this planet having biology. Will it probably be a different planet that happens with? Yeah, I think so. I think it probably won't be this planet, and we'll find out something along the way. But I do think it's going to be a planet. I think that we're going to get better at stuff because we're going to keep funding science. We're going to fight it out, and then we'll look back 20 years later and we'll call the moment that first outside of the solar system biology was found. We're going to pretend that it was a specific date when a paper got published rather than a whole sliding scale of fighting and progress and challenges and people looking at things from different angles and trying to interrogate it and pull it apart in every single way possible, because that is what science is. And I love that. And I love turning it on really big questions like this, because as much as I am really confident that life is not something that just happened on Earth, it will be a very big deal, and I hope that it happens in my life, that there becomes some amount of scientific consensus around the fact that we have indeed seen that we are not the only system of living chemistry in our galaxy. And that'll be nice. There's one system of living chemistry that you definitely don't want to forget about, and that is the moms in your life. Go to good.store and check out all of our Mother's Day specials. And you can write a little note. You're my favorite system of living chemistry. And this system of living chemistry would not exist if it were not for yours, which is true. A heartfelt message to a mom.